says A. How many agrees? Every hand should be raised. Every head up. So burner pressure. So Zach. So what was your?
So whenever they say like mixture control position, is that in reference to the engine condition lever?
So when we talked about controls, what controls did we talk about on a turbine?
Engine condition, propeller, and then throttle.
So that's a turboprop. You have power lever, propeller lever, and condition lever.
Yeah.
What about a turbofan?
Oh, it does say turbojet. That's a good point. You just got throttle.
You just got power levers.
That's a good point.
And that makes all the magic happen with the fuel. So what type of engine would have a mixture control?
Turboprop.
Recip,
They change the words all the time, so I
Bam.
don't know.
Now that's a good thought. Like, are they trying to trick you up? Trip
Like
you up.
the inlet fits the weeds, not the diaphragm.
But what does? Okay, I don't want to get too much into the weeds because recips is a whole other class. Anyone know what the mixture control does?
Yeah.
Just like fuel air mixture.
Fuel air mixture.
Yeah.
Do we control how much fuel, like fuel air mixture on a turbine? Whole different operation. Right. And what are some other names for burner pressure? Compressor outlet. Diffuser. Good. Very good. And just to remember, that is not the pressure within the burner can. It is the pressure right before it. Any questions? Please. If a turbine engine is unable to reach takeoff EPR before its EGT limit is reached, this is an indication that the fuel control must be replaced, or EGT controller is out of adjustment, or compressor may be contaminated or damaged. C. Excellent. Any questions on that one? What is this for anyone? Sure.
So is that, by saying C, is saying like the compressor is damaged, so it's not able to produce enough compression? Is that, or like suck enough air? Is that the idea behind that?
So, follow up to that, not answering you directly. For anyone, what is EPR?
Engine pressure ratio.
Engine pressure ratio. And what does that mean? What is that a ratio of?
Air intake versus output.
Inlet to exhaust, or close. So turbine outlet compared to compressor inlet. And why would we be concerned with EPR? What is that telling us?
How much thrust?
Yes, how much thrust we're getting, and very commonly that's going to be an instrument in the cockpit that is an indication of our thrust. So, if we're not at our normal takeoff thrust, but our exhaust gas temperature, unable to reach EPR before it's EGT. So our EGT is limited, it's at its peak, but we're not getting the thrust we need because our compressor isn't giving us the compression it needs. Any, yeah.
How would you know if your controller is out of adjustment or low?
Do we have an exhaust gas temperature controller?
Just read it.
Right. It's just a thermocouple temperature probe sensing that. We can't control our exhaust gas. It will be what it will be. We're controlling fuel and all this other stuff, but not. We don't have anything in the exhaust to control the temperature. So there's Any other questions or comments on that one? cycle is known as the constant what? Pressure cycle. If you don't know it, you better know it now. Constant pressure cycle. Very good. Did anybody have a question on that? Charlie. Continued and or excessive heat and centrifugal force on turbine engine rotor blades is likely to cause what? Profile, creep, or galling. He says C, potentially B. Interesting. What's your final answer?
B.
Very good. Yes. So, what, this is for anyone, what is creep as related to turbos?
Stretching of blade.
Stretching out and elongating because it's heating up, so now it can have malformation and the centrifugal forces filling it out, stretching it out. What is, as related to turbines, galling? Anyone?
It's transfer rubbing.
Yes. It's a result of rubbing together and metal transferring from one component to another. And what does it mean when it talks about blade profile?
Reduced tip thickness.
Reduced tip thickness for what purpose?
So it doesn't break off?
Yes. So if it rubs against the case, it just wears the tip, it doesn't snap the whole blade off.
So is it first creep then galling?
So would heat and centrifugal force necessarily, well, if it creeps out so much that it's hitting the case, then maybe it could develop into galling. But initially, and it says likely to cause. So the most probable cause, initial cause would be.
Question on that, would you have to measure each individual blade to make sure it's not creeping?
There are blade measurements that you take. Well, and so one of the things we did on PT6 was you take a special gauge and you measure the distance between the tips of the blade and the case all the way around. And it would give you what that should be. How then? If the RPM of an axial flow compressor remains constant, the angle of attack on the rotor blades can be changed by changing the velocity of the airflow, changing the compressor diameter, or increasing the pressure ratio.
I think A.
Excellent. Correct. Changing the velocity of the airflow. So this is, any questions on this question or why it is?
You know why?
So, do you remember kind of the two vectors that we talked about when it comes to angle of attack? What causes the angle of the relative airflow to the compressor blade? Yeah. Yes. So when you have, let me make sure I draw this correctly. So let's say we have our compressor blade in there. That's not quite right, but something like an airflow, kind of like that. And let's put our direction of rotation. So this is our whole compressor disc rotating. So it's rotating like that. And here's the front of the engine. So forward speed coming from. Correct. So it is like that. Where is my air relative to rotation coming from? Correct. So because it's moving like this, it's feeling the air hitting it like that. So about, let's make it easy. Let's say we have 50% of our air coming from this way, 50% of our air coming from this way. About what angle would the blades be feeling the air is hitting it at? Yeah, something like that. So our blades are feeling that airflow about like that. So, depending how these change, will change this vector. So, if our RPM remains constant, then the only thing that's changing the angle of attack is the velocity of the airflow coming in. So if we slow down our airspeed of the airflow coming in, or this is a little different than this question, just going more to compress. So what would happen if this slows down too much with this speeding up too much? Compressor stall, and now we have too great of an angle of attack and compressor blade stall. So what is something that you can change how much air is coming in here, and that is some engines will have inlet guide vanes up here, and that was in one of the videos I showed close to the beginning, where on the front of your engine are inlet guide vanes that you can open up or close off depending what airflow you need, and they can have variable stator vanes at different stages. Questions? Confusion?
Yeah, I'm confused with your bottom arrow, that's signifying air?
The airflow relative, so
So the rotor is rotating down
right.
in this case.
So if my rotor is spinning like that, it's going to feel the air hitting it. Yeah. But yeah, this moving from I assume congratulations.
Assuming that's a pass. That's a pass. No, you failed.
Go Mike.
He gets to try again.
More money.
Did I answer your question then?
I think so, yeah.
Yeah, so like if I'm spinning it like that, it's feeling the air hitting it here. Any other questions? This one is for this turbine blade of cookies. Neat. Which of the following variables affect the inlet air density of a turbine engine? And we have speed of aircraft, compression ratio, and ambient temperature, or speed of aircraft, altitude, and ambient temperature, or compression ratio, turbine inlet temperature, and turbine and compressor efficiency. So go A, speed of aircraft, compression ratio, and ambient temperature.
Oh, sorry, not compression rate, but speed.
Very good catch. Excellent, yep. So speed of the aircraft, how fast you're going forward, the altitude, as density changes and ambient temperature affects density. Any questions on? Now, Parker, which of the following factors affect the thermal efficiency of a turbine engine? Have ambient temperature, speed of aircraft, altitude, or turbine inlet temperature, compression ratio, and turbine compressor efficiency, or turbine inlet temperature and ambient temperature. Perfect. Excellent. So, what is, for anyone, what is thermal efficiency? What does that have to do with the engine?
Like how hot it can get before damage.
So we have a limiting factor, we have how hot it can get before
Like,
damage.
out of the potential energy of the fuel, it's how much is made into heat instead of thrust.
Get a gold star. So, it is, how, you said that so well. Can you repeat that one more time to everyone listening?
Potential energy of the fuel, it's how much is made into heat instead of thrust.
Or how much,
But,
yeah,
Yeah, like how much,
energy is
like how much is wasted making heat.
right, and how much is useful. Yes, or used, correct. So the more that we use that energy from the fuel, the more efficient our engine is. So that will depend on the hotter we can get it, the more we can burn it, so turbine inlet temperature. Compression ratio, the more compressed air we can deliver, the better. And then how efficient is our compressor to give the compression ratio, and how efficient is our turbine to extract that energy. So, any questions?
Hey Christina?
Yes.
Last year, during the turbine class, there seemed to be some confusion between this question and the question before it.
Yes.
Okay, so what I shared with the class is when you have variables affecting the inlet air density of a turbine engine, the inlet air density is the air coming in, so that's external of the inside of the engine. So the answer will be everything that has to do with atmosphere. The next question is the thermal efficiency of inside the engine. So the answer will have everything that has to do with inside the engine. So if you look at the answers, A is knocked out because they're talking about altitude. C is knocked out because they're talking about ambient temperature. So B is the only thing that has everything to do with inside the engine. Just one way to look at it.
That is excellent clarification. And a very, simple way, outside versus inside. Thank you. Any other questions? Joey, you've migrated. The exhaust section of a turbine engine is designed to do what? Impart a high exit velocity to the exhaust gases, to increase temperature, therefore increasing velocity, or decrease temperature, therefore decreasing pressure. Increase temperature and therefore increase velocity. How many are in agreement? Uh-oh. How many are sleeping? All right. How many would say Charlie? Oh, yeah. So, how would we say alpha? Good. So, yeah. The
turboprops?
So if you look at the duct, like the airframe duct on King Air, like they will a little bit, but you're having so little thrust ending up coming out of the exhaust that it doesn't count so much. I mean, you get a teeny tiny bit.
But
But
they'll still try to do, like, with whatever they have, they'll
Yeah.
try to speed it up just for
Generally.
extra, whatever.
Yep. Generally speaking, but sometimes like not enough in the ball. Continue. A cool-off period prior to shutdown of a turbine engine is accomplished in order to allow the turbine wheel to cool down before the case contracts around it, to prevent vapor lock in the fuel control or fuel lines, or prevent seizure of the engine bearings.
Alpha?
Excellent. Allow that turbine wheel to cool, but not spring. Any questions on this? John? What type of igniter plug is used in the low tension ignition system of an aircraft turbofan engine? The low voltage, high amperage glow plug, self-ionizing or shunted gap type plug, or recessed surface gap plug? B. Excellent. And this is that one I had an extra special slide on because just the design of a low tension ignition, they call it self-ionizing, and the way it's jumping the gap, a shunted gap type plug. Yeah.
So with low tension, it has that coil back gap plug, right? Is that true for?
It has,
turbofans or no?
say it again, Nathan.
Is there a coil at the plug? Is that?
So the coil one is on the glow plugs.
Okay.
Where this is, if you look, I think the book has this example.
You mean the coil that makes the high voltage?
Yeah, that's one.
Yeah, the transformer.
Okay.
I believe the answer to that is yes.
Right.
It should be right at the plug, like your car is low tension.
Because this is one that's similar to your car, right? Being low tension.
I'm gonna try this to curve.
Different, it's an igniter.
Yeah.
Right, it's not.
Yeah, around that.
Yeah.
These are igniter, they're not like spark plugs on a receipt.
Right.
It's a different design.
High tension is the one. I think it's the word.
Do you guys understanding about what the self-ionizing or the shunted gap is?
You were paying attention.
Okay,
Well,
maybe I can explain it this way. Maybe.
We'll take a front view of the igniter. That's the center electrode, okay? So on a low tension, we need help to get the spark across to ground. So what they do is this area here is actually kind of like a semiconductor. So it'll help the spark get to here by ionizing the surface, or it's like a semiconductor to help have low conductivity through here so the spark will follow that path. We need that help because it's low tension, okay? And so this area will be kind of like a self-ionizing area in here. For a high tension, when you're really blasting that spark, no, you don't need any help in here at all. That spark's gonna hit that ground on the end of that plug. Does that make kind of sense? If you look at this semiconductor material in here, that'll help pass the current from the center and create that spark.
So on that one, it's actually, there's actual material between it, it's not just air gap?
Correct. So, and I think there's a picture in your book. If we look at the side view, your center electrode is like this. And then here's the outer shell. this is all filled in, and this is about level right in here. It's all filled in with that semiconductor material. Does that make sense? So give you a little visual like that. It'll help you on that, understanding that. You want this back
Oh,
out?
sure. Thank you. Any other questions on that? Sure. What term is used to describe a permanent and cumulative deformation of the turbine blades of a turbojet engine? Stretch, distortion, or creep? Very good. Creep is that permanent, because as it happens, it's not going back and builds up over time, so it keeps getting worse and worse. Playa. What is the purpose of the dump valve used on aircraft gas turbine engines? The fuel is quickly cut off, the nozzles and the manifolds are drained, preventing fuel boiling off as a result of residual engine heat, or the valve controls compressor stall by dumping compressor bleed air from the compressor discharge port under certain conditions, or maintains minimum fuel pressure to the engine fuel control unit inlet, and dumps excessive fuel back to the inlet of the engine-driven fuel pumps.
Bravo.
Bravo, he says. And how many agree? All right. So to simplify, it's saying what's the purpose of a dump valve. So we've got it controls compressor stall as an option, or dumps fuel as an option, or maintains fuel pressure. So they've got Bravo. How they would say Charlie? All right. Anybody for Alpha? Wow, the few and the brave. So the dump valve on a turbine engine is, it could be in different places. On the PT6, that's going to be right here at the bottom of the fuel manifold. And its purpose is as fuel pressure from the pump decreases on shutdown, there's a valve that moves back in the dump valve, stops fuel, and then therefore dumps residual fuel out of the manifold. Decaying air, dumps on the ground, some systems don't recover that fuel.
So what's the one called in the compressor?
That's exactly what I was going to ask you. So what is the one called?
The pressure regulator?
Very close. Bleed valve. And about where would that be? Here's a compressor bleed valve. And it should say compressor bleed valve. It might just be bleed valve. But yeah, so bleed valve is going to bleed off excess air we don't need. Dump valve, dumping fuel. So I think there will be a question, or we might have heard it yesterday, on the bleed valve. And yeah, they love to try to
Question.
trick you. Yeah.
So the answer in Bravo, does it actually dump bleed air,
By dumping compressor bleed
or
air,
it just dump compressor air?
it's regulated.
Like
compressor
bleed air
bleed air.
from the compressor,
Right.
would it dump that bleed air overboard, or would it
That's a
take
good point.
air from the compressor itself and dump that overboard?
Like it's not, like on here, that's just taking it off the bottom of the compressor, it's not waiting till it's in the bleed air tube. Very good point. I forget what their bleed valve question is like, if it would put that in there. Yeah. Any other questions on that? All right. Gas. In what section of a turbojet engine is the jet nozzle located? Combustion, turbine, or exhaust?
Turbine.
And this is a tricky question. So, keyword is jet nozzle. nozzle diaphragm. Nozzle diaphragm or turbine nozzle, and again, this is tricky, but when they say jet nozzle, they're referring to the duct on the exhaust. So,
The thing,
basically, I think you memorize.
so like the turbine drive things are also called the nozzle though, right?
They are called just nozzle or nozzle diaphragm or turbine nozzle. They shouldn't, at least in test questions, they won't call that the jet nozzle. If it's called jet nozzle, that's exhaust. If you see just nozzle or nozzle diaphragm, turbine nozzle, that's turbine. But what is the purpose of turbine nozzles? Direct the air and increase velocity, and jet nozzle is also increasing velocity. So their purposes is why they're both called nozzles, but you know, you have the jet nozzle and the exhaust nozzle diaphragm of the turbine.
Why do they have so many terms for one thing like this? It's just called.
It's a question I've been wondering this whole course.
The FAA doesn't do that, it's manufacturers.
So go find manufacturer engineer. I can be a little hard on engineers because my brother's an engineer. So I said, why?
So is the jet nozzle the whole exhaust section?
It would be, let me see if it clarifies what it,
Like, is it just every dumping nozzle? That seems
turbine
to-
engine exhaust duct is called the exhaust nozzle. So,
Right, the converging duct thing.
right, your converging duct,
Just
Yeah, that tail cone is a aircraft item,
yes,
not an engine item.
The converging duct, did you say?
yes,
So would that be the very last?
correct,
Okay.
correct, yeah.
It's not the diverging duct that's in front of the converging duct, it's just the last one?
Correct.
Okay.
Yes. This one's for Isaac. And we've got two statements. I'll read through them and then you decide what's true or false or, yeah. So number one, accumulation of contaminants in the compressor of a turbojet engine reduces aerodynamic efficiency of the blades. Number two, two common methods for removing dirt deposits from turbojet engine compressor blades are a fluid wash and an abrasive grit blast.
Charlie.
Both are true.
Right.
Any questions? Elijah, which of the following can cause fan blade shingling in a turbofan engine? Would it be over temperature, or large rapid throttle movements, or engine overspeed and or fog? I don't know that we talked real specifically about shingling, so if you want to give your best guess, you can. I also have a picture I'll bring up. You want to take a guess, or I
I'm
can?
gonna say C.
Excellent. Yeah. So what it is, it happens when the mid-span shrouds start to overlap, like shingles on the roof of a house. And that's happening because you oversped or it's been hit by pod and, yeah, starting to damage. And then that obviously can begin to cause damage.
I can't really tell what's happening.
It's not real obvious. This is mainly to show you the mid-span shrouds, but you can see where if this whole thing would come together, where they would start to kind of overlap.
Wait, what is overlapping?
The mid-span shrouds, like right there,
Overlapping with what?
with each other, like from one to the next.
To go through the,
So right here,
through the blade?
kind of. So it's not penetrating another blade, but you can see this one And this one should be separate, but they're starting to twink, overlap each other. Does that make
I'll just memorize what she
sense? Or maybe Kirk has a better explanation of shingling. And I'll put these, PowerPoints, try to remember to post them this afternoon. So when you see this, like, on your own screen, you might go see a little better.
The correct answer was C.
Correct. Over speed or five. Okay, people are groaning. Take a break. Come back at 12:30.
Yeah.
No Sam today. So
Fun?
sad.
Oh, anyhow.
What's that?
He needs just some relaxation.
I'm busy trying to, I looked at my codes and trying to figure out which questions I got wrong. I
Yes.
think I'm remembering most of them.
How'd you do?
Good.
89.
Nice. Oh, that's good.
Knocked it out of the park. Yeah.
How did the, your,
Nervous the whole time?
What's that?
Nervous the whole time?
And once I got going, I was actually feeling pretty good.
I mean, I'll make it full time, but I'll sit here the whole
I find the first like 5 questions I overthink everything.
Yes.
I know this, but like, I think it's just, as you get going, okay, click, 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 click.
You have your own place.
I was a lot more nervous on my general than I was on the other thing. But I studied a lot harder for that for himself.
Yeah. I increased by 2 points. I got 87 on the general.
How many did you miss?
It'd be 11.
How many did you miss on your general?
I'm not sure. 6 or 7 maybe. It's a little
So I
weird.
guess-
Basically, whatever you got wrong, it sends up 100 questions. I'm guessing it's a point each.
Yeah. I got 7 wrong on mine and I got a 93.
There it is.
I got 7 wrong on my general and I got an 86.
There's less questions.
So 7 was my
I just did a quick.
number.
There's a couple, I mean, I was so upset at one question. It said for phosphate ester.
No,
What about phosphate?
What? Yeah, but it said what,
Right.
I never worked right, I started.
seals. And it had Teflon and butyl.
Yeah.
I picked butyl. But I'm like, that is
Turn on the.
because they're both correct.
You could do both. Teflon's gonna be right every time.
But if I didn't, I don't think I got it wrong. I picked butyl, I don't think I got code for it, so I got it right, I think.
Yeah.
But I'm
Same.
So,
I made at least one.
good.
That's
Kept going in intervals.
Okay.
And I had to reduce the angle.
Bottom is 130, high is
130.
And then after that, you know, we sat down after that, you know.
Well, now you're signing the contract. Now you're not going every day.
1.27, 1.3.
Yeah, great.
All that references to yeah, I saw 2.5 hours.
Oh, what?
Oh, Ryan, I have a.
Good.
We could get two inches thinner. That works. What? To make?
Did you get it?
Yeah, to make.
That'd be so great.
Yeah.
Well, the due date was Wednesday, so I have, but the video thing that you have to make a video,
Oh.
why you should get it. And so I thought it was an about me video, and so I made this whole video and it took me about an hour, cause I had to do
Oh,
some
yeah, he did.
retries, right? Nothing was perfect, nothing was okay.
I went
And I noticed and then I'm like, no, this is why I should get it, so I was like, why I should get this, and I'm like, a little bit about me. No, yeah, so, and I messed up so bad at it, and I was like, tools will help me later, cause I need those tools. Tools would be great. So funny on it. I was like, how am I supposed to say, I need these tools without saying, I need these tools? Not like, how many more ways can I say it?
How much do those
Thank you for keeping my.
I don't know, they're not cheap.
Bad.
They're just gonna be freaking, you wanna purchase me, dude?
I mean, right here.
What? Alright, that'll keep me
I'll
awake.
take the tools that I need.
Thanks, Sam.
You're freaking bidding war. I don't know, my nephew's asking if you have price.
Oh, good job, Dan.
He said he wants to buy, but he's not doing it.
Or we can both buy
sure.
both at 10 per
He does. Oh, I thought you meant Zach. I thought you meant Zach. The man you were arguing with.
Alright, let's get started on ye oh, it's important.
They're doing, we're studying.
I mean,
I know, that's why it's
I would
More
go through
interest.
the run. Here is a picture we found of a mid-span shroud on a blade, just to give you another look at what that would look like. And then these are sliding together one blade to the next. That's where the shingling is.
So that shingling is when two blades contact each other at that
The
point?
mid-span shroud portion is overlapping. For you, or
Close.
three. So, Cindy, compressor stall A condition known as hot streaking in turbine engines is caused by partially clogged fuel nozzle, a misaligned combustion liner, or excessive fuel flow.
A.
Excellent. Partially clogged fuel nozzle. That's when it's, instead of, ooh, what is going wrong with the fuel nozzle for anyone? Right, what would be causing the hot streaking? What actually is that? And what does the clogging do to our fuel
Deformed onion.
flow? Yeah, it deforms the onion. And now we're not atomizing that fuel, we might just be getting a shriek of fuel. And Corbin, how is the speed of the APU controlled? Is it APU throttle setting and ECU, or operates at max RPM by itself, or the FCU schedules fuel to maintain RPMs? Very good. Our fuel control unit, about what percentage does an APU run at? 100%. So, depending how much load we're taking off of it, it'll need more fuel to maintain 100%, or if we're decreasing load, now we can decrease fuel to maintain 100%. Any questions on that? And Stephen, what is the greatest load on an APU? Pneumatic loads, electrical loads, or engine starting amperage draw? Excellent. Pneumatic loads. Austin, what is the purpose of having an APU on an aircraft? Is it to provide secondary source of bleed air and hydraulics during emergencies, to provide alternative source to power the cabin, operate flight control, to produce more thrust while on the ground, or provide alternative source of electricity and bleed air during emergencies and ground operations? Very good. Bleed air, electricity for emergencies and ground ops. Any questions on that one? Now here's a tricky one, maybe, hopefully not. Going way back to the very first day of lecture. This question isn't hasn't been in your essay prepware. Oh, Zach, would you like to answer?
Yeah, I can.
I can pull a name too. You look very excited though. All right, so just hold on a minute. I'm going to read through these, and then you tell me which one these go with. Well, actually, I'll read one at a time, and you give me.
Got it.
So, A, we have a back up again. These are 4 definitions, and we have 4 types of jets. So, you gotta tell me which one of these goes with which definition. You're gonna see something very similar to this in your final, where you have to match correctly. So our options are a ramjet, pulse jet, rocket, and gas turbine. First definition. Which one of these is a non-air breathing engine that carries its own fuel and oxygen needed for fuel burn?
Rocket.
Very good. B. Air intake duct is equipped with shutter valves that are spring-loaded open and pneumatically closed as the air inside the combustion chamber expands.
Bullshit.
Very good. C. Must be moving forward at high velocity before it is able to generate thrust. Excellent. And I'll read the last definition so you're familiar with it. Uses a gaseous fluid as a working medium and producing either shaft horsepower, jet thrust, or both. Somebody had to do it. Gas turbine. So just be familiar with those definitions. That is the end of review. Any questions on anything? Any questions? Last questions for Kirk? Of anything that you ponder? You very good question. So that is, when he's talking about the fuel nozzle itself is aimed to be spraying kind of like this. And that's spraying so you have a ring of fire. I'm trying to not say that. Around your combustion liner, unless you're too young. You have a nice arc of flame the whole way around, which is where your air is coming in, that's where you want it to combust, and then it'll expand back there. Because you don't want your fuel, like other options would be if your nozzle is pointing this way, or now, you have more likelihood that it can spray into this portion and damage that with heat. Or this way, this is even closer, it could be damaging that. So by spraying it this way, as long as you're having proper airflow coming around the cooling rings, that's protecting the liner, creating an air blanket. So then you just have the flame front coming around.
Does that actually make the flame rotate?
It's a really good question. You're trying to, due to the design of the perforations, is trying to stabilize the air. Really good question, I don't know. I have to think it through, or ask when Josh can ask John. Yeah, I don't think it would be really actually rotating this. You have airflow coming in like this the whole way around, kind of stabilize it.
Yeah, I heard that JARS is coming this summer to do a PT6. Is that gonna be for the class?
Yes.
Oh, okay.
I think the plan is when they come, I think, this is still getting solidified, but I think it's when they do the consults, because our maintenance guys will be coming for that they're gonna do a presentation on fuel control for the PT6, which is it's in depth and it's good. So make sure that day that you bring your coffee and are fully awake, because it's excellent information. Any other questions?
Yesterday there was a question, something about compressor stall. Wait, I forget what the question was, but I don't remember. I didn't understand exactly what's going on. But something about the air coming into the inlet.
Yes, and we actually they'll ask you several questions on that. There's another question today, and I went over a little bit more. Ooh, is there a volunteer who wants to try to explain? Because the best way to learn is by teaching.
Teach them what a compressor stall?
Yes, and the direction of airflow and what is affecting, how those are affecting a compressor stall. Okay.
I think I get, like we were saying a couple questions ago,
Yeah.
too high angle of attack, but I think the question yesterday was like how you get too high of an attack. Is that?
I think it was. So there's a couple of different questions. So what's causing it, this was my compressor blades rotating this direction. So since it's rotating that way, my airflow that the blades are feeling would be coming up this way. They're rotating down, and so it's feeling air hitting here. So that's due to RPM. And then due to forward speed of the aircraft, it's feeling air coming in like this, just like a wing. Because of those two, one coming up this way, one coming in that way, we have a vector. So the way the blades are actually feeling the airflow is going to be at an angle. So if we have too high of rotation, not enough airflow in inlet, it brings our vector down too much, and now we have too high angle of attack, and the stall can happen. And I think yesterday, it might have been talking about the variable guide vanes, because that can control, because the variable guide vanes would be in front of the compressor rotor, and that can control the amount of airflow coming in.
Okay.
I had a couple, Nate, I think you were first.
So the arrow that's pointing up, I mean, that's not actual air movement, right? It's just a.
Correct. That's how these blades are feeling the air hitting them. Good clarification, yes.
So maybe someone asked this and I wasn't paying attention, but wouldn't the airfoils be the other way on the fan?
So I made it this way because if they're, let me, yeah, everybody help me think this through. Is this correct? So if they're like an airfoil, and let's just draw a wing like that. It's hard to draw it upside down. But this is more drastic. Your compressor airfoils aren't going to be that drastic. But on which side is going to be my lower pressure?
On the longer curve side.
Down here, and then higher pressure up here. So
Oh, I see.
that's why I drew them like that. It would depend what, yeah. Depends what direction it's designed to rotate. Any other questions? So, plan for today is Dean is going to pull out our APU and do some runs for us. So, we'll let him know we're ready, and then just kind of stay close here, because I don't want us all, everybody running out and like messing him up getting it ready. But we'll do it as a group, and then he can do a couple more runs with different people getting in closer. I guarantee everybody going to hear it. So please make sure you have your hearing protection, because it screams super loud. It will damage your hearing. So everyone, make sure you have good hearing protection, and we'll see if, yeah, Dean will be ready. In addition to that, after probably his first run or so, then I'll start running people through PT6 orals. So I'll see who's on the paper, otherwise I'll just start driving people. And if you don't do your oral today, you must do it on Monday. So keep that in mind. Finish up any Moodle labs you need to. Study for the final. It will be written prepware for this, not the oral. Any questions? All right. I'll clean up here. Actually, I'll let Dean know where we'll be ready, and then I'll clean this up, and then fairly soon we should be